Good day, everyone. Today, we're going to report about the multivariate analysis. I am Salome Alce, together with my partner, Ma'am Annabel Aninion. First, we're going to define first what is the multivariate analysis. Multivariate analysis is a powerful statistical technique that is widely used in the social sciences. So, as social studies students, it is used to study complex relationships and patterns involving multiple variables. In the field of social studies, multivariate analysis can be applied in various ways to gain a deeper understanding of social phenomena. That is the use of multivariate analysis. But in general, multivariate analysis is a statistical technique used to analyze data sets that involve multiple variables. It is employed to understand relationship patterns and associations among these variables. So we are going to proceed about the multivariate data analysis techniques. We have the dependence methods and the interdependence method. So the dependence methods explain or predict a dependent variables on the basis of two or more independent variable. Example, in the dependence method, when we are going to relate that one in the social studies, just like the dependent variable is global temperature. So, how the independent variable are being interrelated to the dependent variable, which is the global temperature. So, the independent variable, the greenhouse gas emission, and the deforestation. In each of these examples, the dependent variable is what researchers are trying to measure, explain, or predict if it's influenced by one or more independent variables that are manipulated or observed in the study. So the relationship between the dependent and the independent variables is central to the analysis and interpretation of the research results. So that is the use of dependence and the interdependence method. Okay. So the interdependence, as I've said, the interdependence methods give us meaning, or it will find out how all variables are being interrelated. So we're going to define how the two are being interrelated. Okay, another example. The dependent variable, we have the pollution levels. So what are the independent variables? We have the emission controls or the industrial activity. So that's okay. The researchers must find how the two are being measured or explained or predict. Okay, by being identified the dependent variable and the independent variable of the two. So we can see and observe how the two are being interrelated. Okay. We have the factor analysis groups variables, the cluster analysis groups cases or respondents, okay, and the multidimensional scaling or the correspondence analysis groups objects. So, the factor analysis groups variable. In the social scientists often use the factor analysis to identify underlying factors that explain correlations between the multiple observed variables. For instance, it can be used to uncover latent factors affecting the responses to a questionnaire about job satisfaction. So how factor analysis being used? So in the social studies, so the social studies students can have a survey questionnaire how the graduate or how the graduates in this current school year have or can be satisfied in their job. So in that survey questionnaire, the factor analysis is being used. Okay, we have the cluster analysis groups. Okay, this technique is used to similar group cases or observations together based on their characteristics in social sciences. It can be applied to segment populations with similar behaviors, attitudes, or preferences such as consumer segmentation or identifying different types of social media users. So marami na siyang pagpipilian. What are the similar behaviors, the attitudes, or the preferences of the consumer? How they are going to identify kung ano yung pinakamalakas when it comes to social media users. Okay, and last we have the multidimensional scaling. So later we're going to explain that one. Okay, we have various multivariate analysis techniques. Include number one, the multiple regression analysis. In general, it is used to assess and analyze a number of independent variables with a dependent variable linear function of the relationship between the statistical methods. But, when you are going to relate that one, in the social studies na field, multiple regression analysis extends linear regression to analyze the relationship between a dependent variable and multiple independent variables simultaneously. It can help understand how several factors contribute to a particular outcome such as voting behavior, healthcare outcomes, or job satisfaction. So yun ang kanilang when we are going to relate that one in the social studies field. Okay. Number two is the logistic regression analysis. In general, sometimes referred to as the choice model. This technique is a variation of multiple regression that allows for the prediction of an event. So, when we are going to see the definition, we have the choice model. So, dalawa lang ang pagpipilian. It's because what is right or what is wrong, depende yan sa subject kung ano yung kanyang pipiliin. But when we are going to relate that one, in the social studies, the logistic regression, the dependent variable is categorical. Maybe it is yes or no, pass or failed. So, logistic regression is used, commonly employed in the social sciences to predict binary outcomes. Binary, dalawa lang. Such as whether a person will vote or not, whether someone will buy a product, or whether a student will graduate. So, meaning to say, choice siya. Ano yung pinipili ng tao. Okay. Number 3 is the multivariate analysis of variance. We have the MANUVA. In general, this technique examines the relationship between several categorical independent variables and two or more metric dependent variables. So, when we are going to relate that one again in the social studies na field, it's because we are social studies students. This technique is an extension of ANOVA, allowing researchers to analyze multiple dependent variables simultaneously. It's commonly used in social sciences to examine differences between groups on multiple outcomes. So, marami siyang pagpipilian. It's because multivariate. ANOVA manggod is isa lang siya. Simple lang. We have number 4, the factor analysis. Factor analysis in general is an independence technique in which there is no dependent variable. The goal of factor analysis is to reduce the redundancy among the variables by using a smaller of factors. As I've said it earlier, the factor analysis can be used in the social studies students when having a survey questionnaire how the employed or the non-employed mga graduates, how they are being satisfied in their job or job satisfaction when we're going to deal that one. So that's the use for the factoring analysis. Okay. Number 5 is the discriminant function analysis. The discriminant function analysis is used to determine the classification of individual statistical methods. So, in relation to the social scientist, used when you want to determine which variables discriminate between two or more groups or categories. It is useful in the social sciences for classifying individuals into groups based on their characteristics or behaviors. So, i-discriminate pag positive siya, okay, go. Pag negative siya, may tendency na pwede mo siyang i-discriminate. That's the use of discriminant function analysis. Number 6 is the cluster analysis. In general definition of cluster analysis, we search for patterns in dataset by grouping the multivariate or the observations into clusters. The goal is to find optimal grouping for which the observation or objects within its cluster are similar, but the clusters are dissimilar to each other. So, the cluster analysis, as I've said it earlier, when we are going to relate that one in the social sciences, it can be applied to segment populations, how the behaviors, the attitudes, or the preferences are being similar, such as the consumer segmentation or identifying the different types of the social media users. Okay. And we have the multi-dimensional scaling or the MDS, the principal component analysis, the correspondence analysis, the canonical correlation analysis, the conjoint analysis, the structural equation modeling or the SEM, and the log linear models. So I'm going to discuss na iilan lang. We have the canonical correlation analysis. When we are going to talk about canonical correlation analysis, is used when you want to examine the relationship between two sets of variables. In social sciences, it can be used to explore how variables in one set, example, the demographic characteristics, how they are related to variables in another set, such as the psychological traits. So, meron siyang connection, interrelated when it comes to the correlation nga, correlational analysis. And then we have the SEM or the structural equation modeling. The structural equation modeling, okay, used to test and develop theoretical models that explain complex relationship among multiple variables. It's valuable in fields like psychology, sociology, and education to examine the relationship between latent constructs and observed variables. So those are the things that I'm going to discuss in the other aspect. Okay. But in general, what is the use of multivariate analysis? So multivariate analysis plays a crucial role in as social sciences students. It can have it can help researchers gain a deeper understanding of a complex relationships and patterns involving multiple variables. We have what are the things that can contribute with the multivariate analysis when it comes to social studies? Number one, understanding the complex relationship. Example, social phenomena are often influenced by multiple factors. So, multivariate analysis allows researchers to examine how different variables interact and affect outcomes. For example, in studying crime rates, researchers can analyze the combined impact of factors like income inequality, education levels, and policing strategies. So that's the use of the multivariate analysis. Okay, we have comparing groups or population. The use of multivariate analysis allows for comparing different groups or population while considering multiple variables. For instance, in political science, researchers can study voting behavior across different demographics, taking into account variables like ages, the income, and the political ideology. Okay. We have the assessing the impact of policies and interventions. So the social studies students can assess multivariate analysis to evaluate the effectiveness of policies, the interventions, or the programs by comparing groups exposed to different treatments or conditions. While controlling for other variables, researchers can assess the true impact of the intervention. So, malaki talaga ang gamit usage when it comes to multivariate analysis in relating to the social sciences students. Okay. Predictive modeling. The use of multivariate analysis techniques such as the regression analysis and machine learning enable researchers to build predictive models. These models can be used to forecast future trends or outcomes based on historical data and various predictor variables, which is valuable in fields like economics and political sciences. So, in summary, multivariate analysis provides the social studies students the tools to analyze complex social phenomena, test hypotheses, making predictions, and draw meaningful insights from the data. So, the multivariate analysis is a fundamental tool in the social sciences students that enhances the rigor and depth of research in various disciplines, including sociology, economics, psychology, political science, and more. So, that's all my report about the introduction and what are the usage of multivariate analysis. So, I'm using only the recording. It's because my notebook is not, di siya magana po, Doc. Okay, thank you so much and good day everyone.
Good afternoon, everyone. In continuation of our report with Ma'am Salome, we will delve further by giving an example using multiple regression analysis as one of the multivariate analysis technique. But before that, let us first define again the multiple linear regression. So multiple linear regression is a method we can use to quantify the relationship between two or more predictor variables in a response variable. It helps us to understand how these predictors collectively influence the outcome. By analyzing the data and fitting a linear equation, we can make predictions, uncover patterns, and gain valuable insights into complex relationships within the dataset. So multiple linear regression is widely employed in various fields such as economics, finance, and the sciences to make informed decisions and forecast future outcomes. So example for multiple linear regression, so we calculate it manually. So suppose we have the following data set with one response variable or the y and the two predictor variables which is x1 and x2. So from our data set we have 1, 2, 3, 4, 5, 6, 7, 8. 8 values or 8 samples in each variables. So using the following steps to fit a multiple linear regression model to this data set. So let us first calculate, step 1, calculate x1 squared. Next is the x sub 2 squared. Then the xy, x1 multiplied by y. Next is x2 multiplied by y. Then variable x1 multiplied by variable x2. So from this, we can have a linear regression model based from our data set. So here in our example, the given example y, our dependent variable, the x1 and the x2 is our independent variable. So first is we have to sum up or add the values, then get the mean. So in getting the mean, we have to, the total, then we have to divide the number of values or the n, which is, the total is 1,452 divided by 8. We get the mean of 181.5. So in x1, we get the total of 555, then divided by 8, we get the mean of 69.375. For the second variable, the x2, we get a total of 145 divided by the 8, which is our given values here. We get the mean of 18.125. So in multiple linear regression models, so we have to calculate the x1 squared. So here, we have here the 60. So 60 squared equals to 3,600. Second is the 62 squared. We get 3,844. Same with 67 and so on and so forth. So then after that, we have to get the sum of the all values given. Next is for the x2, we get the squared of this x2. So 22 times 22, we get the 484. Then 25 times 25, we get 625. Then 24 times 24, we got 576. Then so on and so forth. Then We get the total of all values here, 2,823. The next process is we have to multiply the x1 times the y variables. So from here, 60 times 140, we got the total of 8,400. Next, 62 times 155, we get a total of 9,610. Next is 67 times 159, we get a total of 10,653. And until such, we multiply all the values from x sub 1 to y. Then, here, we have to add all these values. Then we get 101,895. So this is our total for all of these x sub 1 y values. Next is we have to solve the x sub 2 times our dependent variable, our y. So first is we have 22 times 140. So we get a total of 3,080. Next is we have to multiply 25 times 155. We got the total of 3,875. Next is 24 multiplied by 159. We get a total of 3,816. Then so on and so forth. Then from here, we have to add all these values in order to have this total 25,364. The next steps is we have to multiply these two variables, our independent variables. So x sub 1 multiplied by x sub 2. So 60 times 22, we get a total of 1,322. 62 times 25, we get a total of 1,550. Then, so on and so forth. So, multiply natin yan. Then, here, if we got all the values here, we have to sum up all of these values. Then, we get a total of 9,859. So, this is our first step in a multiple linear regression model. Second step, or the step 2, we calculate the regression sums. So next, make the following regression sum calculations. So here is the formula for the summation of x1 squared. So here it is, equals x1 squared, the summation of x1 squared minus summation of x1, then squared, then divided by the n, or the given values here, our samples. So we get the total of 38,767. So here's the x1 squared. So we have to what we call this, by following this equation, minus the 555, the summing up of x1, which is here. Then this 555 raised to the power of 2 divided by 8, we get a total of 263.875. So here. Another is the summation of x2 squared. So the formula is equals to summation of x2 squared minus the summation of x2, then times squared divided by n. So our n is, we have 8 values, 8 samples. So summation of x2 raised to 2 equals So the values of summation of 2 raised to 2 is 2,823. So here, minus 145, our summation of x2. So this is it. Then squared. So then we divide it by 8, which is our samples. Total of 194.875. So same process with the rest of the equation for the summation of x1 multiplied by y. So we get the regression sums of 1,162.5. For the summation of x2 times y, we get the regression sums of negative 953.5. And the last is the summation of x1 times x2. So we get the regression sums of negative 200.375. So next is we have to calculate the beta O, beta 1, and beta 2. So the formula to calculate the B1 is like this. The summation of x2 squared times the summation of x1y minus the summation of x1 times x2 multiplied by the summation of x2 times y. Then we divided this by summation of x1 squared times summation of x2 squared minus the summation of x1 times x2 squared. So we use this formula. So all of these values is we already have from our total kanina. So thus B1 equals 194.875. So where's that? 194.875. That is the summation of x squared, x sub 2 squared. So x sub 2 squared. So here, the regression sums. 194.875. Then, we multiplied it by the summation of x1 y. So where is this x1 y? So here, the 1,162.5. Then we have to minus summation of x1 and x2. So summation of x1 and x2. So negative 200.375. So here, then we're going to multiply this summation of x2y. So where is the x2y? So here, the negative 953.5. So here. Then we're going to divide this into summation of x1 squared. So where is the x1 squared? So here, 263.875. Then we have to multiply this to summation of x2 squared. So 194. So here, 194.875 minus the summation of x1 times x2 squared. So summation of x1 and x2. So we get the negative 200.375. Then squared. Then, following those equations, we get the total of 3.148. So this is our B1. Next is we have the formula to calculate the B2. So, following also the formula, same as what we calculate in B1. Thus, we get a total of B2 into negative 1.656. Next is the formula to calculate B0, beta 0, is equal y minus B1 times x1 minus B2 times x2. So thus, B beta 0 equals to 181.5. So our y, so this is the means. So this is the means of our independent variable. So 181.5 minus the B1 times x1. So where is the B1? The B1 here is this 3.148 times the x1. x1 is, the mean of the x1 is 69.375. So here. Minus B2. So where is our B2? Our B2 is negative 1.656 multiplied by our x2. So our x2's mean is 18.125. Then we got our total of B0 into negative 6.867. So later on, we will know the, or we will interpret this B1, B1, B2, and B0. So step 4, place B0, B1, and B2 in the estimated linear regression equation. So here is our estimated linear regression equation. So from our example, we have y, B0 or beta 0 is we have negative 6.867. Then for our B1, we have 3.14. Then the x1. So since addition to, then our B2 is negative. So we have to multiply the sign. So we get the negative, the minus here. So B2 is negative 1.656, then x2. So this is our equation, a linear regression equation. So how to interpret a multiple linear regression equation? So this is our equation. So paano natin ito i-interpret? Okay. B0 is equal to negative 6.867. So, this is the y-intercept. So, ito yung ating y-intercept. Or the constant term in the equation. So, constant pala ito sa ating equation. So, when both predictor variables are equal to 0, so meaning to say x1 and x2 are equal to 0, the mean value for our y is negative 6.867. So in other words, when the predictors have no effect, so both are zero. So the estimated average value of y is negative 6.867. Okay, next. For our B1, so our B1 is, we have 3.148. So this is the coefficient for the predictor variable x1. So a 1 unit increase in x1. So sa x1 to na coefficient. It represents the change in the estimated mean value of y for 1 unit increase. So 1 unit increase in x1 is associated with a 3.148 unit increase in y. So, on average, assuming x2 is held constant. So, yung x2 natin is constant. So, in this case, a 1 unit increase in x1 is associated with an average increase of 3.148 units in our y. Okay. For B2, our B2, this is for our second variable. So our B2 is negative 1.656. So this is the coefficient for the predictor variable x2. It represents the change in the estimated mean value of y for 1 unit increase in x2. So for 1 unit increase in x2 is associated with a 1.656 unit decrease in y on average. So assuming x1 is held constant. So in this case, a 1 unit increase. So in 1 unit increase in x2 is associated with an average decrease. So associated with an average decrease of our y. So with the value of 1.656 in y. So in summary, this linear equation describes how changes in the predictor variables x1 and x2 are associated with changes in the estimated mean value of y. So it provides insights into how each predictor contributes to the estimated outcome, taking into account the other predictors' values. Okay? So that's all for our example. Okay, we have here our case study. So this is from World Applied Sciences Journal 29, 271-276-2014. So the study is from 2014. So, na-publicize to sa 2014 pa. So the title is Impact of Technology on Performance of Employees. So how's the impact of the technology on the performance of the employees? So a case study on Allied Bank Ltd in Pakistan. Institute of Business and Management or IBAN-M. Alright, so submitted November 28, 2013, then accepted on January 1, 2014, then published by the same month, January 8, 2014. So, abstract, technology has fundamental importance in every industry. So, financial institutions have highly been influenced by technology. So, banks have created different delivery channels through investment in technology. So, the aim of this study is to examine the effects of information technology on performance of Allied Bank's employees. So the data was gathered through unstructured interviews and responses were analyzed to the IBM SPSS text analysis. So it was figured out that the technology greatly escalates the productivity of employees along with time saving. So because of the technology, nakasave sila ng time sa kanilang working processes. So it greatly affects the workload on employees and ensures control over mistakes and frauds. So quick access to information and ease of use enables the bank employees to deliver quality service. So, however, the organization which implement new technologies should provide proper training to its employees. So it will increase their performance. Of course, similarly, all the prerequisites should be fulfilled before starting the implementation process. So failure to which could result in poor performance as well as bad customer service. So kailangan talaga nila ng training so that they can have a successful implementation of this technology, of this project. So, methodology in finding sa case study. So, detailed interviews were conducted to achieve the objectives of the research. So, there are 32 employees from different fields were interviewed. So, employees were asked by different questions to evaluate the impact of technology on their performance. So, the detailed responses were coded into short words and different categories were made to analyze the response using. The results of this research indicate that the new technology has strong impact on the performance of employees of the Allied Bank. So the results are, so it enable user to prepare financial report. So financial report is usually uh, gathered or been reported every month, so easily and accurately. So it also results in increased functionality and improved accuracy. So according to Ombate et al., 10 concluded that direct relationship exists between technology and service quality in banking industry. So there is the direct relationship between the technology and the service quality in the banking industry. Next is the financial institution use technology in their working. So it will result in better service quality as well as enhancing the productivity of employees. So the conclusion of the study is investment technology has vital importance in every field. So to complete efficiency, organizations need to adapt and implement technology at every level. So ang nangyari kasi is sa project na ito is merong ginawa na MIS, so the Management Information System para sa kanilang data. So investment of organization in new technology has good impact on the performance of the employees. So it increases their efficiency and productivity. Of course naman, it also make the organizations more competitive regarding customer service like the case of Allied Bank. It has become more customers focused and service oriented. So dahil sa MIS, mapadali na lang ang kanilang mga ginagawang trabaho. It can also make the user more comfortable to his working because it reduces a lot of manual work which is consume extra energy and time. So, na-conserve ang nakasave sila og time, no? Wala na tong mga volume of paperworks. It's because they use the technology, which is the MIS. So that is our case study with regard to our relate to multiple regression, multiple linear regression. So they use the SPSS in coding the variables. So that's all for our report. Thank you.